An empirical formula is the lowest whole number ratio of atoms in a compound. So for instance, if we had the compound H2O2, hydrogen peroxide, the molecular or true formula is 2 oxygens and 2 hydrogens. Now, the empirical formula is the lowest ratio or the reduced form. So HO would be the empirical formula. So this is the molecular formula or true formula, and the empirical formula is the reduced form. We can reduce this to the lowest ratio of HO, 1 hydrogen to 1 oxygen. So this is the empirical formula. Sometimes the empirical and molecular formulas are the same, and sometimes they're different. Let's look at the process for calculating an empirical formula. Phosphine is a highly toxic compound used for pest and rodent control. If a sample of phosphine contains 0.456 grams of phosphorus and 0.0440 grams of hydrogen, what is its empirical formula? Well, the first step here is we need to get these mass numbers, and we need to convert those to units of moles. Since chemical formulas are in units of moles, we'll need to convert mass to moles. So step 1, we could say, is convert mass to moles. So we have 0.456 grams of phosphorus, and we have 0.0440 grams of hydrogen. So let's convert those values to moles. We'll need the molar mass for each element. So the molar mass for phosphorus is 30.97 grams of phosphorus per every 1 mole of phosphorus. And then the molar mass of hydrogen is 1.01 grams of hydrogen per every 1 mole of hydrogen. And so this will convert from grams to moles for each element. We can do our calculations there. And so we'll divide this number by that number. We get 0.0147 moles of phosphorus, 0.0436 moles of hydrogen. The next step is we need to figure out in a simple whole number ratio how these two relate to each other. Remember, we're trying to get to something like this. So we need simple whole numbers to compare them. So to do that, we can divide by the smallest number of moles. So step 2 is divide by the smallest number of moles. So we can write our expression here, phosphorus, hydrogen. Now, we're going to divide the number of moles of phosphorus, which is 0.0147 moles, by the smallest number, which also happens to be the same number, since phosphorus has the smallest number of moles, so 0.0147 for phosphorus. Now for hydrogen, the number of moles of hydrogen is 0.0436, and that's divided by the smallest number of these two, which is 0.0147. So for phosphorus, it crosses out, it's the same number, and it makes a 1. Phosphorus 1. Hydrogen, let's divide those numbers. 0.0436 divided by 0.0147. That comes out to 2.965, or we could round that to 2.97. Now, it's very close to the whole number 3, but it's not exact. So, when it's close enough, if it's within 0.1, then we can just round it to the nearest whole number. When it's not within 0.1, we're going to use this guide here to multiply and get a whole number by that way. We'll see an example like that in a moment. But this one is close enough. Measured numbers have imperfections, so that's where the small difference comes from. So we're going to round that number to 3. Rounds to 3. So then we can state that our empirical formula is P1H3. And there we go. P1H3. Let's try another problem. So we're going to look now at some problems where we have the percentage given to us. So empirical formulas. It's from percent composition. If ascorbic acid contains carbon at 40.9%, hydrogen at 4.58%, and oxygen at 54.5%, what is the empirical formula of ascorbic acid? Now, the percentage here can be interpreted as the portion in mass in 100 grams of the compound. So we can interpret a percent in this way. So 40.9%, for instance, 40.9% is number of parts in 100 parts. So we can interpret that as 40.9 grams of the part in 100 grams of the whole. So we can use the percentage and make that into mass units by this means. So instead of percent, we're going to imagine we have 100 grams of each thing, and we'll just take those percentages and we will consider them as mass, as grams out of 100 grams. So we have 40.9% of hydrogen, and we have 4.58%. Oops, this one was carbon. So 40.9% carbon, and then hydrogen is 4.58%, and oxygen is 54.5%. So we're going to interpret those values as mass. So 40.9% in 100 grams of the substance, that would be 40.9 grams of carbon. And 4.58% by mass in 100 grams, that would be 4.58 grams of hydrogen. And in 100 grams of the substance, 54.5% would be 54.5 grams of oxygen. So now we can continue this as we've done before. we will convert our mass value to moles. The molar mass for carbon is 12.01 grams per mole, and for hydrogen it's 1.01 grams per mole, and then for oxygen it's 16, right here, 16 grams per mole. And so that's of oxygen, this one is of hydrogen, and this one is of carbon. So figure out the number of moles then for each. 40.9 divided by 12. 12.01, that is. So that comes out to 3.41 mole. Then we have 4.58 divided by 1.01. And that comes out to 4.53 mole. And then we have 54.3 divided by 16. And so that gives us 3.39 mole. And this is moles of carbon, this is moles of hydrogen, this is moles of oxygen. So the next step now is to divide by the smallest number of moles. So we can see that these two are very similar, but let's go ahead and we'll use the 3.39 mole value for the smallest number. So we have C and HO. Carbon, it's 3.41 divided by 3.39. Hydrogen, it's 4.53 divided by 3.39. Oxygen, it's 3.39 divided by 3.39. So for carbon, that number is going to be very, very close to 1. These numbers are very close. If you divide those, 3.41 divided by 3.39, it's very, very, very close to 1. So we're going to assume that that one is 1. The imperfections come from the fact these are measured numbers. Hydrogen, 4.53 divided by 3.39, that gives us 1.34, and oxygen again makes a 1. Now, if this decimal number here is greater than 0.1 away from the whole number, we can't simply just round it to the nearest whole number. We can't simply just round this to a 1. In this case, we need to multiply all the numbers proportionally by a small integer that will make this a whole number. So 0.34, that's very close here to 0.33 as a decimal. And so that means we need to multiply everything by 3, all of the numbers by 3, which will give us a whole number. And you can see the other situations that could come up as well. 0.2 we multiply by 5, 0.25 by 4, 0.5 we multiply by 2, and 0.67 by 3. So let's multiply by